Well, the answer is about 5.5 degrees. And let's see how we calculate that. Well, first we need to calculate the range of the cannon. How do we do that? Well, let's look at our initial velocity vector. The cannon fires at a speed of 56 meters per second at an angle of 45 degrees because that optimizes the range. Now we want to break this into components, v0x and v0y. We can do some trigonometry to show that the x and y components are both equal to 39.6 meters per second. Well, if I'm going to know how far this cannonball is going to go, I should probably know how long it's going to spend in the air. Let's use the y component of velocity to do that. Looking at the trajectory of this ball, I want to first find how long it takes to get to the very top. That's when the vertical component velocity will be equal to 0. Using this equation, and plugging in what we know, and remember in this case acceleration is downward, so negative, we find it takes 3.96 seconds to get to the top of the trajectory, which means it will take another 3.96 to get down, which results in a total time of 7.92 seconds. Now we know in the x direction, speed isn't going to be changing. There's no acceleration in the x direction. So if I look at this equation, this term goes to 0, and we're left with this. So what's the range of the cannon? How far can it reach? Delta x? Well, it's just the x component of velocity, 39.6, times the time, which gives us 314 meters. If you got this far, good work. We're almost towards the end. Now we just need to convert this somehow into an angular size. Well, looking at this angle beta, we know this flagpole has a height of 30 meters. And in fact, it looks like we know the opposite and the adjacent sides. So we can write the tangent of beta is 30 over 314. If I ask Google what's the arctan of 30 over 314 in degrees, because remember that's how we go from ratios to angles, it gives me a value of 5.5 degrees. Good work.